This is another in the series Fiber Optics Live from the Fiber Optic Association. These are live demonstrations of how optical fiber works. In this video, we're going to look at fiber optic connectors, and we're going to look at their performance factors, specifically the loss mechanisms that affect their performance. To demonstrate how fiber works, we're going to use this 30mm plastic rod. And to effectively get light in and out of it, we're going to polish the end. And we're polishing it just like we polish an optical connector, using in fact the same film that we use for polishing connectors. For our light source, we're going to use a laser pointer. Here you can see how it is scattered by the imperfect finish on the end of the plastic rod and how light is carried down the rod. If we shine a laser pointer in the other end of the plastic rod, it will light up the end of the rod from scattering off the imperfect finish and exits to show the light pattern out of the rod on our background. This is how we're going to show how light travels in an optical fiber. Our major concern with the performance of optical fiber connectors is loss. How much light is lost in the joint between the two fibers. And this is an effect of the end finish of the fibers, any dirt on them, and the geometry of the connection between the two fibers. We can illustrate this with our plastic rod. Now we have two plastic rods, both polished on the end, and we can join them together just like two fibers are joined in a fiber optic connector. When we put light in, you can see the light scattered off the imperfect finish at the end, and the light coming back to the right, which is caused by the reflectance at the joint between the two fibers. So there's our imperfect joint. Let's show the effect of a gap between the two fibers. You can see the light on the background that's coming out of the transmitting fiber and not being coupled into the receiving fiber. We can also offset the cores of the fiber, and you can see on the background the light that's not coupled through the joint due to the misalignment of the two cores. Finally, we can look at the effect of angularity. By moving the fiber on the right so that it's at an angle, you'll see on the background and off to the side the light that's not being coupled into the second fiber. There are the examples visible of what causes the loss in an optical fiber connection. We're the Fiber Optic Association, the professional society of fiber optics. Don't miss our other Fiber Optics Live demonstrations, as well as our lectures on fiber optics and premises cabling, and all the hands-on videos we have on our YouTube channel.